Hello, today what we're going to be doing is we're going to be looking at how to solve some limits. And some of these limits come from sequences or problem set 2, and some come from problem set 3, but I just decided to combine this part because I think a lot of it is just knowing some cool tricks and going from there. So let's start then. Okay. Let's start with the first limit. So limit as n approaches infinity for cos squared of n over 2 to the power of n. And so here, because we kind of see cos, what we're going to do is we're going to use the squeeze theorem. Now, just to make clear, what is squeeze theorem? Squeeze theorem basically says that if you have two things, if you have two sequences, this, and then let's pick a different color, let's pick red, and like this, if they kind of converge here, and let's continue making this, so this goes over here, and this goes over here, that if you know that your function, your sequence, is in between black and red, and you know that it is always bounded by black and red, then you kind of know that it only has one place to go, and it kind of goes right over here. A cool example that I liked is that imagine that you have a wall, right? So here's our wall. We have a big wall, and your little mouse that wants to get through to the other side of the wall. So here's our mouse. I'm going to do a terrible depiction of a mouse. There, it has some whiskers. If it wants to get through the wall, right, and there's only one hole in this wall, then you know that it has to go through this hole to end up on the other side. So if you know that the mouse is here, and then there's that same mouse, it ended up on the other side of the wall, then you know it had to go through this hole. But then, if, for instance, it wasn't just that little piece it wasn't just a hole that was there. But for instance, it was a segment of a wall. So let's say that my wall, there was a gap from over here to over here. Then when my mouse is going through, if my mouse ends up on the other side, you don't know if it went through here or through here or if it went through the center. All you know that it went somewhere through here, but you don't know exactly where it went. And then you can't really use the squeeze theorem. So for the squeeze theorem, what needs to happen is that your limit on the left side, when you're approaching something, and your limit from the right side, they have to equal to each other. And then you know that like that mouse had to go through that hole. If they don't equal to each other, then you're going to have that spacing in between. And then you don't know if the mouse went to the left side, to the right side, or again through the middle. Okay, now we have cos squared n. And now we know that cos n is bounded by 1 and -1. So then what we're going to do is we're going to square both sides. So we're going to square both sides. So we're going to get 1 is bigger or equal to cos squared of n is smaller than 1. And then if we divide both sides by 2 to the power of n, so 1 over 2 to the power of n, cos squared n over 2 to the power of n is smaller than 1 over 2 to the power of n. And what we're going to do is we're going to basically check if our right side and our left side have the same limit, and they do. As n approaches infinity, this is going to become 0 because 1 over infinity, it approaches 0. And over here, 1 over 2n, that also approaches 0. And so now you know that cos squared over n over 2 to the power of n, as n approaches infinity, this is going to approach 0. And let's check. It's always fun to check. So let's go on Desmos quickly and check whether I'm right. So cos squared n, cos squared x over over 2 to the power of x. And we see that as it reaches infinity, it goes to 0. So look at us, we were right. We have something really cool happening on that side. So that's how the squeeze theorem kind of works. Let's go on to another question now. Okay, B. So limit as n approaches infinity for 3n plus 2 over 5n. So how do we calculate this limit? So what we're going to do is we are going to go like this. We're going to go 3n times 3 to the power of 2 over 5 to the power of n. And then what's going to happen is this is going to equal to 9, but this doesn't matter at when n equals infinity, times 3/5 to the power of n. And now 3/5 to the power of n actually goes to 0 when n reaches infinity. And you can think of it like this. If you have x to the power of n, where x is greater than 1, then as n reaches infinity, this is going towards infinity. On the other hand, if you have x which is smaller than 1, or more precise, it's in between 0 and 1, then as n reaches infinity, this is going to go to 0. And you can think of it again as 0.1 or 10 to the power of -1 times x. So it's the same thing as 1 over 10 to the power of x. And so as x reaches a really high number, this is all going to become 0 because it's going to be 1 over infinity. And that's why this function goes to 0. Okay, let's look at our next function. So we're going to get limit as n approaches infinity for 3n to the power of 5 minus 2n cubed plus 1 over 1 minus n to the power of 5. And so over here, what we're going to see is that this is actually going to go to a limit of -3, I think. And the reason I know that is because what I look at the highest power. And that's going to be n to the power of 5 here when I open the brackets, and n to the power of 5 here. So all the other n's, they don't really matter now, because as you go to infinity, those n's kind of not matter as much. A better way to show this is like if we take out n to the power of 5 from here. So we're going to get, so if we take out n to the power of 5, we have n to the power of 5, 3 minus 2 over n squared, plus 1 over n to the power of 5. And then on the bottom, when we open up the brackets, what we're going to get is, we're going to get some long equation. And then when we factor n to the power of 5, it's all going to be like 1 over n to the power of 5, something, something, something. Something, something, something. And then the last term would be n to the power of 5. And then it's actually going to be minus n to the power of 5, because it's going to be negative n times negative n times negative n times negative n, and so on and so forth. So that's where you get a negative n 5. So when you reach that out, it's just going to be left with -1. And then if you evaluate at n equals infinity, so these two cancel out, but then all 1 over n to the 5 is 0. So everything is going to become 0, except for the two terms that you're going to have left is 3 over -1, which is going to equal to -3. And again, if you don't trust, let's just quickly check this. So we're going to go like this. So 3x to the power of 5 minus 2x to the power of 3 plus 1 over 1 minus x to the power of 5. And so what do we see? We see that we don't see anything here. And that's because I didn't put it to the power of. So we see some really fun function. X to the power of 5. And there you go. So as we see, this approaches -3. So, well, we're only looking at infinity, but here it approaches -3 as we get closer. Cool. Let's do the last one. So limit as n approaches infinity. So this is, we're going to get root of n squared plus n minus n squared minus n. And so now what we're going to do is we're just going to say, well, imagine that this is infinity, right? So this goes to somewhere like infinity. And this goes to infinity. So if we subtract these two, it's going to be 0. No, I'm kidding. I'm kidding. Sorry. No, we wouldn't do that. I'm sorry. We wouldn't do that. So what we're going to do instead is we're going to take the conjugate. So we're going to multiply this by root of n squared plus n plus root of n squared minus n over n squared plus n square root plus root of n squared plus n. So when we take the conjugate, what's going to happen is this is going to equal to, so the top kind of cancels out, so we're going to get n squared minus n squared plus n minus n squared minus n over root of n squared plus n plus root of n squared plus n squared minus n, my apologies, minus n. So then on the top, what's going to happen is we're going to get 2n. And on the bottom, what we're going to do is we're going to factor out n squared from the square roots. So we're going to get absolute value of n. An absolute value is because if you take root of n squared, you're going to get absolute value of n. So it's going to be, and okay, I'll quickly explain this. So the reason you're going to get absolute value is because if this is negative, like the value is always going to be positive no matter if n is negative or positive, and that's why it's always going to be absolute value. So if you put like -3 in here, you would get -3 squared. The square root of that is going to be 3. If you input 3, you would also just get 3. That's why it's just absolute value. So then we're going to get absolute value of, and then in the brackets, it's going to be square root of 1 plus 1 over n plus root of 1 plus 1 minus 1 over n. 1 minus over 1 over n. And so right now, because our function is going to infinity, we actually don't really care about the absolute value, but don't always be so confident. So in some of the limits that we're going to do with functions, you can actually approach it from both sides, and then you really need to be careful. So then we're going to kind of cancel these out, and then we're going to evaluate at n equals infinity. So that equals to 2 over root of 1 plus 1 over n. So that's going to be 1 plus 1 minus 0. So 1 over n is 0, 1 over n is 0 because it's going to infinity. That's going to equal 1 plus 1, which is just equal to 1. And let's check, because we always like to check. We shouldn't just trust blindly. One of these days I'll enter it, and it won't end up being what I told. And it's going to be very awkward for everybody, including me who's recording. Plus x. Or maybe if that happens, I'll just forgo the half an hour footage that I potentially had and just say, nope, I am refilming this. Okay, square root of x squared minus x. And so what do we see? It goes to 1 over here. As x approaches infinity, it goes to 1. Interestingly enough, what I do want to show you here is that if you're going to over here, if you're taking the negative, so if we were looking at how it goes to negative infinity, it goes to -1. And the reason for that, and we're going to see this a bit more when we do some other limits, is that the reason for this is that if n was going to negative infinity, then everything up to this step would be the same. The only big difference that would happen is that when you take the when you remove the absolute value of n, sorry, the bottom would be positive, but the top would still be negative. So what would end up happening is that you get -2 over the bottom would end up being 2, and that's why it would be -1. Because absolute value of n would make negative infinity positive infinity, and but n would still be negative, and that's why we'd still get that negative on top, and that's why it would be -1, which again we also see in our function over here. Cool. So for problem number 2, I'm going to leave that for you, but the basic concept there is also just to take the conjugate. Let's move on to some more fun limits in problem set number 3. I'm going to do a couple, not all of them, the ones that I think are really fun and tricky. And if you have questions, you can always ask me tomorrow. So, let's do A quickly, just because it's quite simple and I think it's good to have some intuition for some of these things. So we're gonna get x squared plus 5x plus 6, and this is a 5, not a 3, 5x plus 6 over x squared plus x minus 6, and this is the limit as x approaches 3. What we're going to do here is that we're going to see that basically x squared and x squared, they have the same power, the same exponent. So this is going to go to 1. And let me show you how I know this. We kind of already demonstrated this when we had like n to the power 5. But if we were to factor out x squared, no, I'm wrong. This doesn't necessarily go to 1. That's my mistake. The mistake I made here is that I thought this would be infinity, but actually you need to be careful. I'll just say I was tricking you. That you need to really pay attention to your limit. So if this was infinity, then yeah, it would be going to 1, but here it's not going to infinity. It's going to a limit of 3. So then, firstly, in all honesty, what you need to do is you need to check whether you can just plug it in and see if there's a value. So if we just plug it in, let's see what happens. We get 9 plus 15. So it's 9 plus 15 plus plus 6 over 9 plus 3 minus 6. And so here what we're going to get is 30 over 6. So this is just 5. So no trickery needed. You just plug in the numbers. Okay. For B is limit as x approaches 0 from the positive side. And that is root of 1 plus x minus 1 over root of x. And this is equal to, so what we're going to do here is we're going to take the conjugate. So we did before, so it's going to be root 1 plus x minus 1 over root of x. Sorry, I have something in my throat. 1 plus x minus 1 times 1 plus x plus 1 over root of 1 plus x plus 1. This is going to equal to, so it's going to be 1 plus x minus 1. And on the bottom, what we're going to get is root of x squared plus x plus root of x. So this is going to equal to x over square root of x squared plus x plus root of x equals to, so we're going to factor out x here from here. So we're going to get x over absolute value of x again, absolute value of x times root of 1 plus 1 over x plus plus root of 1 over x, and that is equal to, so you can simplify these because you know they're both coming to positive, so it's going to be 1 over root of 1 plus root root of 1 plus 1 over x plus root of 1 over x. And because x is going to 0, all of this is going to equal to infinity. And this is going to equal to infinity, so it's basically going to be 1 over infinity, which is just going to be 0. Let's check. So then we're going to take limit. So it's square root of 1 plus x minus 1 over square root of x. And what do we see? That as it's approaching from the left, from the right side, it's approaching 0, which is what we got, which is really cool. Okay, C, I'm going to do C quickly. So it's going to be sine of 2x over sine of x as limit as x approaches 0. So the problem here that we probably can see, sorry, the problem here is that if we just plug in 0, we're going to get 0 over 0, which we don't like. So we are going to use the squeeze theorem to see if we can figure this out. So sine of 2x, x is bounded by 1 and -1, 1 and -1. So then what's going to happen is we're going to, I don't know why I put sine of x. So it's just sine of 2x. And now if we divide both sides by sine of x, we can get -1 over sine of x is smaller than sine, small equal to sine of 2x over sine of x is smaller than 1 over, is 1 or smaller than sine of x. And so now we know that as we know that this doesn't have a limit, I think, because as x approaches 0, 1 over 0 is negative infinity, and this is infinity. Let's check, because I might be wrong here, and then I will take a look quickly, and it will be awkward in the video. So be it. Sine of 2x over sine x, x. So as it's approaching 0, it's going to approach 2. And why did I get that wrong? Let's see where I went wrong. Hmm. Give me a sec. That's a pretty cool solution. Okay. So here it's actually a bit more fun than I perceived it to be. And I'm sorry I led you by the nose. So you don't actually use squeeze theorem here, but I'm glad I did take it up because I don't think you would have seen. I didn't see this right away. Probably you didn't too. So for this one, what we're going to do is we're going to use the identity that sine 2x is actually equal to 2 sine x cos x. And what this comes to show you also is that don't just blindly see sine and cosine and do squeeze theorem. Also keep in mind some other stuff. But if you do 2 sine x over cos x over sine x, you can simplify your sine x's and you're going to get 2 cos x. And then cos x at 0 is equal to 1, so the identity is going to be 2. And that's what we actually see over here, that it is in fact 2. So yes, usually when you see sine and cosine, you're going to use squeeze theorem, but also keep in mind these different options that you do have and these different tools in your tool belt. Okay. Okay, I'm gonna do one more, and then if there are any questions, you can come ask me tomorrow or just message me, and then I might just take them up separately. But I want to do this one because of a very interesting property. So I'm gonna do limit as x approaches 1, x squared plus x minus 2 over x squared minus 1. So over here, what we're gonna do is we're gonna go. So can we factor this? So we're going to factor things quickly. So first we're going to go x plus 1 times x minus 1. And then on the top, what is it going to be? On the top, it is going to be, I think it's x minus 2 and x plus 2 and x plus and x minus 1. So x plus 2, x minus 1, an absolute value of that. Okay. And now what you basically need to be careful of is the switching of signs. So you're gonna get two limits here. It's gonna be 3 over 2 and negative 3 over 2. And that's because your absolute value functions, it's gonna change the sign at 1 because x squared plus 2x, x squared plus x minus 2, it's gonna look something like this. So it's a 1 and a negative 2. It looks something like this. So in between 2 and negative 1, it's negative. So that's where your sign change happens. And because of that, if you approach, so if we take the limit, so limit of x approaching 1 from the positive side, limit of x approaching 1 from the positive side, we're going to get x plus 2, x minus 1, so value over x plus 1, x minus 1. And here, because this is going to be positive, you can just simply simplify this and you're going to get 3 over 2. But now if we check it from the negative side, so limit of x approaching 1 from the negative side, it's going to become negative x plus 2 over x plus 1. And the negative there is because the bottom, so if you approach 1 from the left side, this bottom one is going to be negative. While on the top, because it's absolute value, it's still going to be positive. So that's why we're going to get negative x plus 2 over x plus 1, which is going to give us negative 3 over 2. So that actually just means that this limit doesn't exist. But again, we can check. We've clearly seen that I can be wrong. I hope it wasn't as awkward as it came out to be. So let's type this in. So it's going to be absolute value x squared plus x minus 2, absolute value, over x squared minus 1. And so as we see over here, we don't have a limit actually because it does do the jump. So here our limit is undefined. And so always just be wary of, especially if you see absolute values, that you are approaching from two different sides. And so because of that, limit might not exist. For all the rest of the limits, find the tricky ones, guys, and bring them in, and then tomorrow I'll take them up. Hopefully this helped. And yeah, good luck on the quiz tomorrow. Or just hopefully, maybe you just passed by and stopped here, and hopefully then you learned something about limits. Thank you. Have a great day.